Neurons in artificial intelligence. AI beginner level. Introduction. Artificial intelligence systems learn patterns from data using models called neural networks. Neural networks are inspired by the human brain, where billions of tiny cells called neurons work together to process information. In artificial intelligence, these biological neurons are imitated using artificial neurons. Artificial neurons are the basic building blocks of neural networks. They receive input data, process it mathematically, and produce an output that can be used by other neurons. Neurons allow AI systems to recognize images, understand speech, detect patterns in data, make predictions, classify information. Understanding neurons is essential for learning machine learning, neural networks, and deep learning. What is a neuron? In artificial intelligence, a neuron is a computational unit that processes input data and produces an output. In simple terms, neuron equals a mathematical function that receives inputs, performs calculations, and produces an output. Example concept. Inputs means neuron means output. Each neuron performs a simple calculation. But when thousands or millions of neurons work together, they can solve complex problems. Biological neurons. Human brain. The concept of artificial neurons comes from biological neurons in the human brain. A biological neuron has several parts. Dendrites receive signals. Cell body processes signals. Axon sends signals to other neurons. Example concept. Signal received means processed means transmitted. Billions of neurons connected together form the human brain's neural network. Artificial neural networks are inspired by this structure. Artificial neuron. An artificial neuron is a simplified mathematical version of a biological neuron. It receives multiple input values, processes them, and produces a single output. Example concept. Input values means weighted calculation means output. Artificial neurons are the fundamental units that make up neural networks. Components of an artificial neuron. An artificial neuron has several important components. Inputs. Inputs are the data values that the neuron receives. Examples of inputs: image pixel values, sensor readings, numerical features from a dataset, text embeddings. Example concept: X1, X2, X3 means inputs to neuron. Weights. Each input has an associated weight. Weights represent the importance of each input. Example concept: input times weight means contribution to neuron output. If a weight is large, that input has a stronger influence on the output. Bias. A bias is an additional parameter added to the weighted sum. Example concept: weighted inputs plus bias. Bias allows the neuron to adjust the output and learn more flexible patterns. Activation function. After calculating the weighted sum, the neuron applies an activation function. Example concept: weighted sum means activation function means output. Activation functions determine whether the neuron should activate. Common activation functions include ReLU, sigmoid, tanh, softmax. Activation functions allow neural networks to learn nonlinear relationships. Mathematical representation of a neuron. The operation performed by a neuron can be represented mathematically. Y equals F, sum underscore, I equals 1, caret, N, W underscore IX underscore I plus B. Where X, I equals input values, W, I equals weights, B equals bias, F equals activation function, Y equals output of the neuron. This equation describes how a neuron processes information. How neurons work together. A single neuron performs a simple calculation. However, Neural networks contain many neurons connected together. Example concept: input neurons, down-pointing arrow; hidden neurons, down-pointing arrow; output neurons. Each neuron passes its output to other neurons in the next layer. This allows the network to learn complex patterns. Example: image recognition. Consider an AI system that recognizes cats in images. Example concept: image pixels means neurons detect edges means neurons detect shapes means cat identified. Early neurons detect simple patterns such as edges. Later neurons detect more complex patterns such as shapes, textures, objects. This layered processing enables advanced image recognition. Role of neurons in neural networks. Neurons play several important roles in neural networks. They allow AI systems to process input data, transform information through layers, detect patterns in data, generate predictions. Example concept: input data means neuron, computations means prediction. Without neurons, neural networks cannot function. Real-world applications of neurons in AI. Neurons are used in many modern AI systems. Computer vision, recognizing objects in images. Speech recognition, understanding spoken language. Natural language processing, analyzing and generating text. Healthcare AI, detecting diseases from medical data. Recommendation systems, suggesting products, movies, or music. Advantages of artificial neurons. Artificial neurons provide several benefits. Advantages include simple computational units, scalable to large networks, capable of learning complex patterns, adaptable to many types of data. Example concept: many simple neurons means powerful AI models. Limitations of artificial neurons. Artificial neurons also have limitations. Limitations include: individual neurons are simple. Large numbers of neurons required for complex tasks. Training networks requires computational power. Example concept: complex problems means require large neural networks. Concepts learned from neurons. Understanding neurons helps learners understand. Checkmark how neural networks process data. Checkmark how machine learning models learn patterns. Checkmark how inputs are transformed into predictions. Checkmark how deep learning models operate. Checkmark how modern AI systems are structured. Neurons are the fundamental building blocks of neural networks and deep learning models. Simple definition. Neuron. Artificial neuron. A computational unit in a neural network that receives inputs, applies weights and an activation function, and produces an output. Final summary. Neurons are the fundamental units of neural networks in artificial intelligence. Inspired by biological neurons in the human brain, artificial neurons receive inputs, perform mathematical calculations, and produce outputs. Each neuron applies weights, bias, and activation functions to process information. When thousands or millions of neurons work together in layers, they form neural networks capable of solving complex problems such as image recognition, speech processing, and language understanding. Understanding neurons is essential for learning machine learning, neural networks, and deep learning.